In this video, we are going to see advantages and disadvantages of the stack. So, advantages of the stack: easy implementation, efficient memory utilization, fast access time, helps in function calls. Stack data structure is easy to implement. Like the concept, or you can see like the principle behind the stack is simple, last in, first out. So there is no complexity in the process actually. So it is easy to implementation. You can use arrays or linked list, anything to implement this particular stack data structure. Efficient memory utilization. Stack uses a continuous block of memory, making it more efficient in memory utilization as compared to other data structures. So obviously, like here, it depends upon the way you implement this, whether you are going with the arrays or linked list actually. And here, like how the memory is going to be used basically. Fast access time. Stack data structure provides fast access time for adding and removing elements, as the elements are added and removed from the top of the stack. So why we say that fast access time is the advantage of the stack is we are not going to search any element and then we are going to take that element actually from the stack. Only the top of the stack we are going to access anytime. We can insert on the top of the stack and we delete from the top of the stack, and we can access anytime only the top of the stack actually. So it is directly the pointer is pointed to that, so it is like no fast access. So helps in function calls. So as we have seen in the previous videos, like the applications of the stack, like the return addresses can be stored in the stack, though, so that helps, like in the function calls actually. So easy implementation without any confusion and all. Uh, no efficient implementation can be done for the function calls and also the recursive function calls. Supports backtracking. Actually, this backtracking can be done using your undo and redo operations actually, which has been specified down also. That is enable undo and redo operations. Actually, undo operation will be helping in supporting the backtracking process. Means we are going to take some steps. Let us say like no 8 queens problem example I'm telling you. 8 queens problem is nothing but we have to place the queen in the like 8 by 8 board actually. So none of the queens should be in the same row, same column, same diagonal actually. So in order to place that, we will keep trying to place each queen. And once like no, if we are able to succeed 8 queens without any backtracking process, fine, good. But if not, like if we are stuck at any particular point of time, then what we will do, we will be going back and try to check whether any other possibilities are there in the previous steps actually. So that is nothing but backtracking, undoing the operation. So that particular case will be helpful using the stack. Used in compiler design. Stack data structure is used in compiler design for parsing and syntax analysis of programming languages. So there are different steps in the compiler design actually: lexical analysis, semantic analysis, syntactic analysis, like this. So in these two steps of the compiler design, that is parsing and syntax analysis, stack will be useful. So as I just now told you, enables and redo operations. For example, you're typing some document actually. So obviously like typo errors, if it comes, if you want to go back, or by mistakenly if you have deleted something and if you want to get it back, we'll do undo the operation, right? So redo also we will be able to do. So these things will be taken care using the stack. That is, if you have done something in the application, that will be stored in the stack. That is, whatever the operation you have done, that will be stored in the stack. So using that stack contents, you will be able to perform the undo and redo operations. And coming to the disadvantages of the stack: limited capacity, no random access, memory management. Limited capacity because if you consider actually the total memory the memory which will be organized in the form of the stack will be very less. So stack data structure has a limited capacity as it holds a fixed number of elements. Normally, when you are implementing a stack in your programs, dynamic stack you can create, at the same time static stack also you can create. But no, like when you're talking about the memory organization, stack size is fixed actually. So if the stack becomes full, adding new elements results in stack overflow, leading to the loss of data. So no random access. As we are discussing during the advantages of the stack, I told you the fast access time is just because we are able to access only the top of the stack. Now, when you are trying to access any other element, that is randomly, like it will take more time actually. It is not actually possible. Means like roundabout way we can do and no access, that is removing the top of the elements and then accessing and putting the elements back to the stack. This way we will be able to do. But in those kind of applications, stack is not correct data structure to use. As random access is not there, it is a disadvantages of the stack. And then coming to the memory management, stack data structure uses a contiguous block of memory, which can result in memory fragmentation if elements are added and removed frequently. So when you are talking like the block of memory is continuous in the case of stack, what will happen here? Suppose if I add 4 elements, 1, 2, 3, 4, then I am removing some particular element. Let me say second element I am removing. So what will happen? Free space will be created in the element where I have deleted. Then what will happen whenever I am adding another element, fifth element will be added after 4 only, but the second element will be free. Not like the fragmentations will be there when you are using stack actually. That is basic stack we can say. That is why memory management is a disadvantages of the stack. So not suitable for certain applications. Now, just now I told you, like wherever random access of the data is required, obviously stack is not suitable for such kinds of applications. So, for example, searching, sorting algorithms are there. Then in that case, stack is not the correct data structure what we can use. Then stack overflow and underflow. So because the size of the stack is fixed in the memory, stack overflow can be there and stack underflow can be there. So if too many elements are pushed onto the stack, you can result to the stack overflow, and it can result stack underflow if too many elements are popped from the stack. Recursive function calls limitations. While stack data structure supports recursive function calls, too many recursive calls can lead to stack overflow, resulting in the termination of the program. So because the stack size is limited, so if we are having more number of recursive function calls when compared to the size of the stack, obviously it will lead to the stack overflow. So that is another disadvantage of the stack. Thank you.